Where does the power of nil-punning come from? In this episode, we're going to explore the power of nil-punning that we went through in the last episode. And I'm going to give my recommendations for how to make the best use of nil-punning. My name is Eric Normand, and I help people thrive with functional programming. Now, this episode is going to be, like the last one, very focused on Clojure and Lisp in general. But I think it's still a good talk about like programming language semantics. And so I hope you learn something even if you're not into Clojure. We're going to touch on JavaScript and Haskell as well. So in the last episode, I talked about what nil-punning was and why it's in Clojure and Lisp and its origins and why we like it. And in this one, I want to talk about something that it just slipped my mind at the end of the episode that I wanted to come back to, and now I'm coming back to it. And that is, where does the power come from? So is nil-punning by itself a powerful idea? And I don't think it is. So before we get into that, what is nil-punning? Nil-punning is simply that nil has different meanings in different contexts. So you can do kind of a pun where you are using a value that could be nil in all these different contexts and relying on the different meanings in those contexts. So, for example, nil means false in a Boolean context. It's not equal to false, but it means false. So it will, if you have an if statement or an if expression, if you have a nil for your test, then it'll use the else branch, just like a false would. Okay. So what that means is if you get a return value from a function, you can say, did I get a value? Because nil represents no value. So did I get a value? Everything will be truthy in that context except nil and false. And so if you're not expecting a Boolean, or you can play with that difference of context, whereas here it means no value, but here it means false, and so that's nil-punning. But that in itself, the fact that it has different meanings in different contexts is not that interesting. It doesn't really give you a ton of power. What does give you the power is that in every time, let's imagine you're designing this language. Every time you make a new context in the semantics of your language, you have a decision to make. What does nil act like in this context? And you can make a good decision, meaning one that's aligned with the design goals of your language. You can make a bad decision, meaning it's inconsistent design goals, and it makes the language wordy. It makes it harder to use. And so that's where the power comes from. It comes from all these decisions. Did you make a really good decision here? And I would argue that in Clojure, a lot of the decisions were really good. Enough where it feels very nice to use nil-punning. Enough of the decision. Not all of them, but enough. There are a lot of places where it causes problems. And for instance, one of those is, I don't know if you would call this nil-punning, but it has the same effect, the same consequences. If you call the keyword function, and I'm going to do this right now at a REPL. If you call the keyword function with nil, it returns nil. And what's happening? Well, keyword really only makes sense. So keyword takes a string and it returns a keyword with that string. So keyword is just a wrapped up string. If you give it something that's not a string or isn't easily turned into a string, like a symbol, like what does it even mean to call keyword on it? So if you pass in a number or a Boolean or a list, like what does it mean to call keyword on this? So it doesn't have a meaning. So what happens in Clojure is nil is returned. So if you pass in a nil, same thing, nil is returned. And it really is just about how keyword is implemented and Clojure's design decision not to check arguments. So Clojure does not, like a lot of dynamically typed languages, one thing they do is they check the arguments as they come into a function. They say, is this a string? No, throw an exception. Clojure doesn't do that. It just lets the expression, it's in an if. It's like, is it a string? Is it a symbol? Is it another keyword? And then nothing else. And so the default for the nothing else case is return nil. And so it just kind of falls off the cond and a nil comes out of the function. So it's not even like a designed thing, right? But it does have the same effect, which is that in the keyword context, nil gives you no keyword, which is represented as a nil. And so nil that comes in some random place, gets passed through a keyword, doesn't throw an exception, comes right out, goes to some other function, gets called there, and then at some point is going to cause a problem, but you don't know where the nil came from because it just flowed right through that keyword function. And you would expect it to blow up or something. And then, some languages it would. So this is one of those problems where I assert that it is a nil-punning, or whatever you want to call this thing that a keyword does, is the wrong decision. Okay. But in general, like I said, I think Clojure did a really good job. Ritiki did a really good job of designing what nil means in each context, so that most of the time you feel like it's a good nil-punning is a good thing. All right, so now I want to talk about my recommendations for nil. And it's just one kind of overarching big recommendation. Because when you're coding, you're, building out a domain model, you're building out systems, you're making all these contexts. You're making new contexts, and you have to decide what every kind of value means in that context. Sometimes nil makes perfect sense in the context. Usually it's like a low-level context. Nil is a low-level value. It has no meaning except I don't have a value for you. It's a pointer that points to nothing. Okay, so you have this nil. Sometimes that makes sense in your context. Okay, like I don't know what to do, so this, or I do know what to do with like if it's an empty collection. Yes, if you're talking about a collection context, nil being an empty collection, that makes a lot of sense, but it doesn't always make sense. And so my recommendation is, one, if it doesn't make sense to give it a meaning, don't give it a meaning, or give it an error, exceptional meaning where it throws an exception so that nil doesn't get bubbled through. Don't try to be too clever and say, oh, nil kind of means this, so I'm going to use it like that. Like, no, do not do that. Make it clear that nil is too little. It doesn't have enough meaning attached to it to actually be useful in this scenario. And check and throw an exception. Don't let it through. Okay? You're not writing the low-level Clojure code. You can make different design decisions for your application. And the second part of that is, what do you do when you have something that kind of is like no answer or whatever? I say use an explicit value. So don't use nil. to represent I didn't get an answer from the server. Use a keyword or some other thing that's not nil that encodes meaning. Because as soon as you say, well, I didn't get an answer from the server, meaning like there was a timeout when I made the request, I didn't get an answer, the server was down, whatever, I didn't get an answer from the server. It's a meaningful answer. Because as soon as you do that, you're going to then say, well, what if we do get an answer from the server, but the answer is, I don't know the answer to that question. So you got the response and the server said, don't know. That could happen too, right? So you need to encode that in some other way. And too often we overload nil because it's usually convenient and it seems to make sense, when you look at each one in isolation. Oh, if there's a timeout, of course, no answer, so nil. Oh, and if the server says nil, then yeah, of course, nil. But then when you put them together, you've lost information because very often in the domain you're working in, a positive answer from the server that says, I don't have an answer, is very different from, I couldn't even reach the server. I don't know what the server will say. That's different. That's a question mark. Whereas the other one is a positive not know. Okay, and so you might want to encode that in your domain. And in fact, I think you probably do want to encode that in your domain. And this is very much like the null object pattern in object-oriented programming. So null object would be to, instead of using a null, you make a new class that implements the same interfaces that represents no person. So the classic example is you need to display like employee information on a screen. And so someone types in, they have a box, they can type in the ID, and then boom, it shows the employee information for that employee ID. Except what do you do if they type in the ID and there is no employee to show? So you return null, and so now everywhere you have to check, is it null? Yes? Okay, then print this string in the first name box, like no person or whatever, even empty string. But you have to have an if-else everywhere to check. If it's null, put this string. Otherwise, call the first name method on the object and then put that there. So you have this if statement that's like everywhere, and it's the same check. Is this null? Is this null? Is this null? Is this null? So what they recommend is make an object that represents a like no person found. And so then all the responses to the methods are indicative of that. So first name would be like NA, last name NA, salary 0 or whatever, whatever it makes sense for your UI, you make that thing. And so then you don't have all the checks in your UI. You can just display whatever the answer is. You just call the method and it never returns a null, so you're good. It's also similar to something that happens in Haskell, for very local things. Sure, use a maybe number, it's fine. But then at some point, you're going to want to encode more meaning than nothing can encode, because you have just the number or nothing, and nothing isn't meaningful enough. It just means I don't have a number. So you make a new type, and it has the number in those cases when you have the number, and then it has other constructors that indicate some other meaningful information. Like same example I had before, you have, couldn't get in touch with the server versus the server answered that it doesn't have an answer. So those are two different cases, and you might want to incorporate them into your domain instead of collapsing everything to the meaningless nil. That's my recommendation, is use nil only if it really, truly makes sense. Okay? Otherwise, you want a more meaningful value. And so if it doesn't make sense, check it as soon as it doesn't make sense and throw. Just don't let it in. Don't let the nil in. And then use these other values. Could be a keyword. Could be, it's Clojure. You're pretty flexible with what you use, but something with more meaning, like a keyword, because it's a string. Really, you can read it. All right. We talked about the power of nil-punning. It comes from the good design decisions. If you don't have good design decisions, nil-punning can be way worse. And in fact, we see that in JavaScript, where null is equal to 0 and it's equal to false. It's just a mess. So instead of saying nil is its own value that is not equal to false, but in a Boolean context, we're going to treat it the same as we treat false. JavaScript equates them. And so then it just causes trouble everywhere. They're not the same. They're different values that happen in this context to have the same meaning. It's a very different thing. And JavaScript got that wrong. We all recognize that. That's why everyone recommends using the triple equals, because that double equals does this like cross-type equality, which is just weird. And causes a lot of trouble. All right. So if you like this episode, please listen to the last one, which was about nil-punning. I go deeper into that. You can go to lispcast.com/podcast, find links to all the old episodes, including audio, video, and text transcripts of all of them. You'll also find links to subscribe. You can subscribe to any of those 3 media types. Also, you can find me on social media. So there'll be links to my Twitter, my email, also LinkedIn. So please get in touch with me. Love to hear your horror stories with nil-punning and Clojure, or your success stories if you have some of those. All right, this has been my thought on functional programming. My name is Eric Normand. Thank you for listening, and as always, rock on.